If flux density F is equal to what will be the effective isotopic radiated power, okay, that is about a, we say it is about a effective isotopic radiated power that is from the source we say, and in a given particular regions, that's why 4 pi term is here, and the distance is r. Okay, so that's why power flux density F is equal to EIRP by 4 pi r square. That will be the transmitting power. Then next, a received power. So generally the received power, we should know that what type of antenna we have and what will be the area, or you can say that physical area of the given receiving antenna. So for this effective area of a receiver, we should know that is AE equal to whatever the antenna efficiency into the whatever the area of the receiving antenna, AR. Okay, area of this receiving antenna. So these are some rays are received, or you can say that this one is nothing but a power density that will F, we can say here, that is watt per meter square. Okay, this one we can say power flux density, that is nothing but a power flux density here, or we can write a word here, power flux density F is equal to this one. This one is a PTGT by 4 pi r square, that is about a transmitting power. Now at a receiver, here this one is about the power received by this given antenna we have the surface. This one is about the surface of an antenna here. So it will receive the power, and that power received is depending upon that what will be the effective area of an antenna, what will be the power density, and what will be the gain of a receiving antenna. Okay, what will be the effective area, what will be the power flux density, and what will be the gain of the receiving antenna. So generally we say that a power received, it is depending upon that how much is the power flux density and what will be the effective area of this receiving antenna. Okay, this generally we say that AR into F, that will be the watt here. Now then we can calculate that what will be the power receiving in terms of the antenna efficiency. So that we can write received power in terms of the antenna efficiency, that will be AR into F, or we will get that equation, that will be A to PTGT by 4 pi r square. Okay, so in terms of the efficiency, antenna efficiency, we are writing the terms. We say that here aperture effective area is nothing but what will be the area of a receiving antenna and the antenna efficiency. So as we have studied earlier, that gain is nothing but, we know that a gain is equal to what, 4 pi AE by lambda square. So that we can rewrite the equation in terms of effective area or a aperture area there, that A is equal to what, that gain into lambda square 4 pi. Now in the above case, AE here, if you see that this AE, so in that case, AE, that is nothing but a effective area of a receiving antenna, that is about AE. So in that case, that gain is nothing but the for the receiving antenna. Here just we are rewriting the term with respect to gain here. But if we write this one is for the receiver, so similarly this one is for the receiver also. Gain is for the receiver. So then we can calculate that a power received, and that will be nothing but what? Again received. Then we have the lambda square. Then we have the term 4 pi. Here this one, and then a PT GT by 4 pi r square. So at the end, PT GT GR divided by 4 pi r. So we have a lambda square here divided by lambda bracket raised to square. And that is nothing but a received power. So gain of the transmitting antenna, gain of the receiving antenna, that is at a distance in a satellite communication. If you see that distance from the earth station to the satellite, that is nothing but a r. And we have this lambda here, that is about the operating wavelength of this antenna here. So now this particular term, if we consider, because you're transmitting signal, okay, here we say from the point source to this distance r here. So that's why this one is nothing but the region. So this one is about a point source. It transmits the signal, that will be a PTGT from the source, and to transmit in this particular region, that is about region is about the R. And then the same if you consider here, in the case of the satellite, we say here it is about a PTGT, that is effective transmitting power, or you can say effective isotope radiated power from this antenna. It will be transmitting, and then it will be receiving at the satellite. And that distance from the earth station to the satellite, that nothing but the R. And the effect occur on the EIRP in this particular region from the transmitting station to the receiving station, means in this particular region, that is of a distance r. So that's why this term 4 pi r square we are getting here. We say that a power received is depending upon that PTGT, means power transmitting or gain transmitting or gain of a receiving antenna, divided by this 4 pi r square by lambda. Now your received power is depending upon this particular factor. Received power is depending upon that distance r as well as the wavelength here. Means received power will be reduced by using this factor. Okay, this 4 pi r by lambda bracket square, means your received power can be reduced by this particular term. So even if we consider that a power transmitting by the antenna, that we say PT, and the gain of the transmitting antenna is GT here. So that will be there, that term will be there. And then again another term is about receiving antenna. Even if these terms are there, but your power received is depending upon this R as well as the lambda wavelength. Means your power received, even if these terms are there, but this term will reduce the power received at this antenna. So that's why this particular factor is nothing but a loss, or we can say that this particular factor is nothing but a free space loss. Free space loss means what? PTGT here, and this 4 pi r by lambda is nothing but this free space loss in the particular given path from the earth station to the satellite here. So we can calculate that a path loss or a path loss factor. So that path loss factor is equal to, we say it is about LP or a free space path loss or a free space path loss LP is equal to the 4 pi r by lambda square bracket. And this one is about a path. And this path loss is depending upon that distance in between the, what we can say, that distance between the transmitter and a receiver. Distance between the transmitter and a receiver. Or you can say that a distance between the source and the receiver. And that lambda is nothing but the wavelength of the signal, and that will be transmitting by the earth station. So lambda is nothing but what is c by f, and that c is the velocity of a light and f is the frequency of a signal that will be propagating from this earth station or a transmitting section. So if we write the equation in terms of a wavelength here, that is about a c by f r square. So in that case, that 4 pi r into f by c. And if you put that c is equal to 3 into 10 power 8 meter per second, so in that case, we'll get that a path loss in terms of directly in terms of a frequency. But if you want the same a path loss in terms of a dB here, we need to separate out the term. So that will be of a 20 log of, that term is about a 4 pi term, and we have this 3 into 10 power 8 plus 20 log of your r is the distance plus a 20 log of whatever the frequency in gigahertz. Okay, so that's a f into 10 power 9. Okay, generally f. Okay, no need to write in the gigahertz and all. 20 log of whatever the frequency we have. So we will get that path loss in a dB, that will be of 20 log r plus 20 log of f plus 92.44 dB. And that is about a constant. That constant comes from this 4 pi by 3 into 10 power 8. That is about a 92.44 here. And this loss occurs because of that spreading of a signal from the earth station to the satellite here. Okay, that is about a from the earth station to the satellite here. And that is not by the any other media. That is just like a loss that we consider, that is about a free space loss or a free space loss or a whichever the path loss we have. That is about your path loss. Then we can find out what will be the link equation. What will be the link equation?